Hi everyone, today in Integrated Math 2 we're going to go over Chapter 2, Lesson 7. Here are your objectives. Make sure you write them down in your notes. Alright, so the greatest integer function is when we have f of x is equal to double bracket x. The type of graph it is known as the disjointed line segments, which means they are not connected. Dis means not, so not joined line segments. And you can see that here. None of them are connected here. The domain is all real numbers, and the range is all integers. So the absolute value function, the parent function, is f of x is equal to the absolute value of x, defined as if x is greater than 0, 0 if x is equal to 0, negative x if x is less than 0. And it's always going to make this V shape for the absolute value function graphs. The domain will be all real numbers, and the range is all non-negative real numbers. And here's just a picture of the different kinds of functions. We talked about the step functions, absolute value functions, and piecewise functions are, just as it sounds, it has pieces to it. So here's one part of the function, the other function is here. But notice this dot is closed, and this one's also an open dot, just like the step function. So keep that in mind. So example 8, we want to graph f of x, which is equal to the absolute value of x plus 3, and state the domain and range. In order to do this, the best way, if we don't know what the graph is going to look like, is to make a t-chart. So x and f of x, we're going to have y, but let's have f of x for now. Let's choose a couple points, -5, -4, -3, let's just say 0, 1, and let's have some positives in there as well. So let's go ahead and plug it in for each of our numbers. So we have the absolute value of -5 plus 3. And that gives us the absolute value of -2, which we can't leave like that because we have to change it to a positive. So it'll be positive 2. Absolute value of -4 plus 3 is equal to absolute value of -1. Must change to a positive, so it's just going to be 1. Then we have absolute value of -3 plus positive 3, which will give us 0, which will remain as 0. So then 0 plus 3 is equal to absolute value of 3, which is still 3. And then we have 1 plus 3 within our absolute value. That'll give us absolute value of 4, which is still 4. And let's do this last one. So 2 plus 3. That gives us absolute value of 5, which is equal to 5. So then we're just going to go ahead and plot the points and connect those dots, because it's going to make a V. And as you can see here, here's our graph. So then, and these are pretty much the same points that we chose, minus a couple different ones. So this one's our 5, 2. This one's our -4, -4, 1. And then -3, 0. -2, 1, and -1, 2, and then 0, 4. So we just connected the dots. And as you can see here, the domain is all real numbers. Remember, the domain is when we're talking about our x's. So there's no limit to our x's. They can keep on going infinitely. And then the range is as long as f of x is greater than or equal to 0. because it won't go any lower than 0. So it has to be greater than or equal to, but it can still include 0. So that's why that's there. And that's it.